First, I will discuss about one case study, actual case study, troubleshooting of the absorption system of chlorination process. This assignment we have done in 2009 for Almol Chemical Industry, Vapi. Now, most probably that industry is now shifted to Vadodara. So, it was a chlorination of organic. It was a middle scale process, but at the same time it was a batch process. So, batch chlorination reactor. Exact reaction I forgot, but let us take example of say chlorination of acetic acid. Chlorination of acetic acid gives monochloroacetic acid plus hydrogen chloride gas. This chlorination of acetic acid is carried out at 100 degrees centigrade temperature in a batch reactor. Reaction is exothermic. And total reaction time is 36 hours. So, in a batch chlorination reactor, via reaction hydrogen chloride gas is generated. In the same case, in a chlorination of acetic acid, one undesirable side reaction is also taking place, that is chlorination of MCA gives dichloroacetic acid plus HCl. So, during the reaction, gas vapor mixture is continuously coming out from the top of the reactor. During the chlorination reaction, gas vapor mixture is continuously coming out from the top of the reactor. That gas vapor mixture contains hydrogen chloride gas plus unconverted chlorine gas plus the vapors of organic, means plus vapors of acetic acid, vapors of monochloroacetic acid, plus vapors of dichloroacetic acid, plus vapors of acetyl chloride, because acetic anhydride is also added in this reactor. It is converted into acetyl chloride, and acetyl chloride acts as a catalyst. So, this gas vapor mixture is allowed to pass through two condenser, primary condenser and secondary condenser. In a primary condenser, cooling water is used as a cooling medium. In a secondary condenser, brine is used as a cooling medium. So, majority of the vapor is condensed and recycled back to the reactor. Then after, the mixture of hydrogen chloride and chlorine that is sent to the absorption system. Next. So, this gas mixture is approximately contains 90% HCl and 10% chlorine. So, in that industry, three large size absorbers were used. The first absorber was graphite block type falling film absorber. Second and third absorbers were packed tower type absorber. In second and third absorber, polypropylene Paul ring was selected as a packing, and total packing height in second and third absorber was 6 meter, and that 6 meter packing was divided in a 3 section. So, height of packing per section was 2 meter. But this absorption system was not working efficiently. Because of the poor performance of this absorption system, that industry was facing three major problems. First problem, significant amount of chlorine and hydrogen chloride gas was coming out from the top of the third absorber, and the same was vented to atmosphere. While as per the norms set by Pollution Control Board, maximum permissible concentration of HCl or chlorine in a vent gas is 30 milligram per meter cube. So approximately 25 ppm. While here 100% pure chlorine and HCl, that also in a significant amount, was vented to atmosphere. That is why that industry received the closure notice from Pollution Control Board. And that is why we have invited as a consultant. So that was the first problem. Second problem faced by that industry related to this absorption system, that was caustic soda consumption in a third absorber was very high. Caustic soda consumption in a third absorber was 5 lakhs rupees per month. 5 lakhs rupees per month. While based on our calculation, it should be around 60,000 rupees per month. Now let me, then in addition to that, there was a third major problem. But before that, I like to tell you about the operation of this absorption system, how they were operating this absorption system. I am starting with the operation of third absorber, last absorber, in which 10% caustic soda solution was selected as a solvent. So first two scrubbers are provided for the absorption of HCl in water. So for a first two scrubber, water is selected as a solvent to absorb the HCl from this mixture, while to absorb the chlorine, 10% NaOH solution is selected as a solvent in a third absorber. So operation of the third absorber was, before starting the process, sufficient amount of 10% NaOH solution was charged in a circulation tank, and then after that solution was recirculated through the absorber by centrifugal pump. They were allowing the recirculation of the solution until the pH of the solution reduced to 9. pH of 10% NaOH solution is very close to 14, slightly less than 14. So when the pH of the recirculating solution reduced to 9, that solution is discarded as a wastewater to ETB plant, and at the same time, fresh 10% solution was charged in a circulation tank. Here one question is, why we cannot reduce the pH up to 7? The problem is, if we allow the reduction in pH below 9, then solid particles of the salt appear in a solution, and those solids are accumulated within the packing and increases the pressure drop across the pack tower. So to avoid that, it is better that we can allow the reduction in pH up to 9. So again, fresh 10% NaOH solution was charged into the circulation tank. That is how they were operating the third absorber. Then second absorber, Before starting the process, DM water or pure water, sufficient amount of pure water was charged in a circulation tank of second absorber. Then they were allowing the recirculation of the solvent until the strength of HCl increases up to 20%. So in a second scrubber, they were allowing to increase the strength of HCl from 0% to 20%. So once they get the 20% strength, the 20% hydrochloric acid that was transferred to storage tank, and at the same time DM water was charged in a. So before starting the process, sufficient amount of 20% hydrochloric acid that was charged in a circulation tank. Then strength of HCl was increased from 20% to 30%. So solution was recirculated through the first absorber until its strength is becoming 30%. So those two absorbers. Only chlorine is to be absorbed in a third absorber. So based on the actual chlorine flow rate that is sent to the absorption system per batch, actual amount of chlorine means actual consumption of the chlorine per batch is known minus chlorine consumed in the reaction. Amount of chlorine consumed in the reaction that we can calculate from the stoichiometry of the reaction, because we know what is the production of MCA per batch, what is the production of DCA per batch. So we can calculate the actual amount of chlorine consumed in the reaction and actual amount of chlorine supplied. So supplied minus consumed, that is the amount of chlorine that is sent to the absorption system per batch. And in a third absorber, there is an absorption chemical reaction. NaOH react with chlorine and 2 NaOH plus chlorine gives sodium hypochlorite plus sodium chloride plus H4. If we like to produce sodium hypochlorite solution, the condition is operating temperature of the absorber should be less than 20 degrees centigrade. If we can keep the operating temperature across the absorber less than 20 degrees centigrade, then we can get desired strength of sodium hypochlorite solution. Otherwise not. And it should be stored also below 20 degrees centigrade. Then third problem that was faced by that industry due to this poor performance of this absorption system, it was they were operating the plant with 50% capacity. Intentionally they were operating the plant with 50% capacity. Otherwise the product demand of that product was very high in the market at that time. But intentionally they were operating the plant with 50% capacity. Why? Because when they were running the plant with 100% capacity, considerable amount of the gas was leaking through the pipe joint and flange joint of inlet pipeline to absorber. This absorption system was kept in an isolated area. It should be kept in an isolated area. So total length of the pipeline from the top of the reactor to absorption system, inlet pipeline, total length of inlet pipeline to absorber was around 10 meter. And it was not a straight pipeline. It was a zigzag pipeline. Involves many pipe joint, elbows and flange joint. So when they were running the plant with 100% capacity, gas was leaking through the elbows and flange joint. So operator refused to run the plant with full capacity, and they were running the plant with only 50% capacity. So company was facing these three major problems. We have done this assignment in 2009. We means myself and Mr. B.I. Bhatt. Mr. B.I. Bhatt is a joint author. We have jointly authored two books on different subjects of chemical. So first, we have asked about the detailed fabrication drawing of three absorbers. So first we have calculated design flow rate of HCl and chlorine because it is a batch process. So there is a variation in the flow rate that is fed to absorption. So one very important point for the design engineer who are designing condenser or absorber for batch process. This point is very important. That is, in a batch reactor, if it is a continuous reactor, then rate of reaction remains constant. If it is a continuous chlorination reactor, then rate of reaction remains constant. So rate of generation of HCl remains constant. But in a batch reactor, when we start the reaction, rate of reaction is maximum. And as the reaction proceeds, rate of reaction decreases with time. And at equilibrium, rate of reaction is reduced to zero. So in a design calculation, for example, in this case, total amount of hydrogen chloride gas generated is 3600 kg of hydrogen chloride gas is generated per batch. That I have determined based on stoichiometry of the reaction. And total reaction time is 36 hours. That means average rate of generation of HCl is 100 kg per hour. But 100 kg per hour is average flow rate. It is not design flow rate. Because starting rate of reaction, starting rate of generation of HCl is quite higher than average value. As a design engineer, I consider starting rate of reaction double than average value. So in this case, I consider design flow rate of HCl 100 into 2 times average value. So that is how we have calculated design flow rate of HCl and chlorine through absorber. And based on that, we have verified the design of all three absorbers. We found that design of all three absorbers were correct. Only there was a one mistake in a design of pack tower regarding the design and selection of packing support. About that I will discuss at last. Otherwise, design of all three absorbers were correct. In fact, they were actually over-designed. Percentage excess heat transfer area of graphite block type falling film absorber was more than 25%. As per our calculation, packing height required in a second scrubber was 2 meter, but packing height provided was 6 meter. So all three scrubbers were actually over-designed. But still, they are not giving desired performance. So then we took the visit of that plant, and in the plant we have seen this process. Immediately I found one common mistake that is done. And that mistake was cooler was not provided in a recirculation line of second scrubber. In a second scrubber, pure water was charged as a solvent and it was allowed to increase the strength of HCl from 0% to 20%, but cooler was not provided. Absorption of HCl in water is highly exothermic. Heat of absorption is 70,000 kilojoule per kilomole of HCl absorbed. So if you calculate the required heat duty of cooler, then it is coming very high. So in fact, very large size cooler is required to install in a circulation. Once I seen that mistake, I told them, let us measure the temperature of this recirculating solvent of second absorber. Let us measure the temperature of this solvent that is used for second absorber. So at that time, temperature of this recirculating solution was 92 degrees centigrade. Temperature was 92 degrees centigrade. Also, they inform us, we have started this plant just half an hour before. Actually, we have received the closure notice from Pollution Control Board, so we cannot start the plant. But just to show the performance of this absorption system, we have started this plant just half an hour before. So within half an hour, the temperature of this circulating solvent reached to 92. Increasing temperature of the solvent decreases the equilibrium solubility of solute. For example, dilute hydrochloric acid is circulated as a solvent. If the temperature of the solution is 50 degrees centigrade, then equilibrium solubility of HCl in water at 50 degrees centigrade is 60%. But at 100 degrees centigrade temperature, equilibrium solubility reduced from 60% to 28%. So, if we do not provide the cooler, and decrease in equilibrium solubility means decrease in drying force available for mass transfer, decrease in the rate of mass transfer, or decrease in the rate of absorption. So rate of absorption is becoming half if we do not provide the cooler. Right? So we have suggested to use, again, hydrochloric acid is highly corrosive. So we have suggested to use graphite block type heat exchanger as a cooler, and heat transfer area required for that cooler was 22 meters square. Means large size cooler was required to install in a circulation line. Same modification we have suggested in a third absorber. Next slide. In a second and third absorber, we have suggested to install the cooler. In a third scrubber, if we allow the increase in the temperature of recirculating solution, because reaction between NaOH and chlorine is exothermic and heat of reaction is significant. So if we do not use the cooler, then the temperature of the recirculating solution continuously increase. And here polypropylene Paul ring is selected as a packing. If polypropylene Paul ring is exposed to higher temperature, say 90 degree and 100 degree centigrade temperature for a long period of time, then it affects on the strength of the packing. Then packing may be crumbled. So stainless steel cell and tube heat exchanger as a cooler that we have suggested to install in a circulation line of third absorber. Another very common mistake that I have identified, that is, first slide. Here in a second and third scrubber, again let us focus on second scrubber. Dilute hydrochloric acid is circulated and recirculated solvent is fed from the top of the tower. The presence of HCl in an incoming solvent, provides the equilibrium limit in a concentration of HCl that is present in the exit gas. If you have the knowledge of gas liquid equilibrium, to find the gas liquid equilibrium data for absorber, either we can apply Raoult's law if it is ideal system, or we can apply Henry's law if it is a real system. If you see any gas liquid equilibrium data, when X is 0, corresponding equilibrium value of Y is also 0. But if X is greater than 0, then corresponding equilibrium value of Y is also greater than 0. For example, in this case, let us consider the case at any instant 18% hydrochloric acid, 18% hydrochloric acid is introduced from the top and its temperature is 100 degrees centigrade. Now, equilibrium partial pressure of HCl over 18% hydrochloric acid at 100 degrees centigrade is 0.04 atmosphere. So, corresponding value of equilibrium value of Y is 0.04. That means it is impossible to get percentage of HCl in exit gas less than 4%. If 18% hydrochloric acid is introduced from the top at 100 degree centigrade temperature, then theoretically it is impossible to get the percentage of HCl in exit gas less than 4%. In actual, this is theoretically. In actual, exit gas that is leaving from the top is contaminated by the liquid particles of hydrochloric acid. So, actual percentage of HCl in exit gas is quite higher than 4%. So, whenever you see this type of the arrangement for a physical absorption, when you see such type of the arrangement, we can say, based on this arrangement, we can say that with this arrangement, 100% absorption of solute in an absorber is not possible. It is impossible to satisfy the norms of pollution control. જ્યારે ઇન્ડસ્ટ્રીમાં હું આ આર્ગ્યુમેન્ટ કરું છું કે તમે આવું રિસર્ક્યુલેશન આપ્યું છે, so it is impossible to satisfy the norms. એ તો મને રીડિંગ બતાવે છે કે આ જુઓ રીડિંગ, અમારે નોર્મ સેટિસ્ફાય થઈ જાય છે. પણ નોર્મ્સ કેવી રીતે સાઈડ એ પણ મને ખબર છે. જ્યારે જીપીસીબીના એન્જિનિયર આવવાના હોય ત્યારે તમે પ્યોર વોટર આમાં ચાર્જ કરી દો અને એ જ વખતે પેલા રીડિંગ લઈ લો, તો ત્યારે તો રીડિંગ આવી જશે. પ્રોબ્લેમ ક્યારે થશે? જ્યારે એચસીએલની સ્ટ્રેન્થ વધશે, એ પછી it is not possible to satisfy the norms. So, to break this equilibrium barrier, we have suggested they can recirculate back the solution, but it should be return back to the top of the second packing section. And instead of charging pure water, sufficient amount of the pure water directly in the circulation tank, instead of that, they should continuously charge pure water to the top of the topmost packing section. For a pure water, X is 0. X means mole fraction of HCl in a pure water is 0. So corresponding equilibrium value of Y is also 0. So then after, theoretically, 100% absorption of HCl in second scrubber is becoming possible. Because eventually exit gas is contacted with pure water. Otherwise, presence of HCl in an incoming solvent cannot reduce the concentration of HCl to 0 because of the equilibrium limitation. Same modification we have also suggested in a third scrubber. In third scrubber, there is no equilibrium limitation, but the problem is they were allowing to decrease the pH of circulating solution from 14 to 9. When pH is reduced to 9, percentage of NaOH in a solution is less than 1%. So when the percentage of NaOH is less than 1%, it provides very low rate of chemical reaction. Rate of chemical reaction directly proportional to concentration of reactant. So 1% NaOH will give very low rate of chemical reaction or very low rate of absorption. So at that time, considerable amount of unabsorbed chlorine may come out from the top of the absorber. So solution is, otherwise based on even calculation, packing height required in a third absorber is 4 meter. Here instead of 4 meter, height provided was 6 meter. 4 meter height is also sufficient. So same modification we have suggested. Recirculated solvent can be recycled back to the top of the second packing section. And instead of charging 10% NaOH solution directly in a circulation tank, they can charge continuously 10% NaOH to the top of the topmost packing section. So in that case, vent gas is eventually contacted with 10% NaOH solution. So this was the second mistake that we have identified. Third mistake that we have identified in the operation of graphite block type falling film absorber. Actually, graphite block type falling film absorber is the most efficient type of absorber for the absorption of HCl in water, because absorption of HCl in water is highly exothermic. So in a graphite block type falling film absorber, both previous slide, both gas and liquid, both gas mixture and liquid solvent are introduced from the top, and we carry out co-current contact. In a graphite block type falling film absorber, first the fabricator fabricate the cubes of graphite. Slide agar. First fabricator fabricate the cubes of graphite. In a cube of graphite, horizontal and vertical holes are drilled. But these horizontal and vertical holes are not passing through each other. There is a graphite wall in between vertical hole and horizontal. First slide. Then these cubes are arranged vertically. Also, they are covered by the headers. So, through the horizontal hole, cooling water is circulated, and in a vertical hole, absorption is carried out. Ideally, in a vertical hole, liquid should fall down in the form of film at periphery, and gas should travel in a central portion. So this type of the two-phase flow is called falling film flow or annular flow. But to get the annular flow within the vertical hole, we have to keep the liquid flow rate very low. So that is the mistake normally done by industry, operators of industry. Here also, solvent was just recirculated by central pump. So liquid flow rate to absorber was very high. What is the limiting value of liquid flow rate? To get the annular flow or falling film flow in a vertical hole, superficial velocity of the liquid should be less than 2 feet per second. 2 feet per second means 0.6 meter per second. So let us fix superficial velocity 0.5 meter per second. So flow rate, volumetric flow rate of liquid should be number of vertical hole into pi by 4 di square, number of vertical hole into pi by 4 di square into 0.5 meter per second. That gives meter cube per second flow rate of liquid. So actual flow rate of liquid to graphite block type falling film absorber should not be greater than this value, 0.5 into flow area, 0.5 into number of vertical hole into pi by 4 d square, where d is the diameter of the hole. So we have suggested to use rotameter in our inlet line of liquid and control the flow rate of liquid below this value, limiting value. And to get the annular flow, same slide. Superficial velocity of gas should be greater than 30 feet per second, means 10 meter per second. It is a normal velocity of the gas that we always get. Gas velocity is always more than 10 meter per second. Only we have to take care about the velocity of liquid. So liquid flow rate must be controlled. It should be kept low. Then we get the falling film flow or annular flow. Otherwise, there are different types of two-phase flow, plug flow, slug flow, mist flow. Otherwise, we will not get the annular flow or falling film flow. Then this absorber cannot work efficiently. Graphite block type absorber can work, falling film absorber can work efficiently only if there is a falling film flow or annular flow through the vertical hole. Otherwise not. So what we have suggested, second slide. We have suggested that operate the graphite block type falling film absorber in a once-through manner. I have referred many technical papers that is published in a technical journal like Chemical Engineering Progress, and many other technical books. One of the book is Absorption, Distillation and Cooling Tower by Norman. In that, this operation of the falling film absorber is discussed in detail. In all this technical literature, it is suggested to operate this absorber in a once-through manner. Do not provide the recirculation. Do not provide the recirculation. So we have suggested to operate the same absorber in a one-stream manner. Instead of 20% hydrochloric acid, we have suggested to use 5% hydrochloric acid as a solvent. 5% hydrochloric acid can be introduced from the top. So in a second scrubber, they can allow to increase the strength of HCl from 0% to 5%, not up to 20%. Because in between these two absorbers, first and second absorber, the first absorber is more efficient as compared to second absorber. While here major load is transferred to second absorber, which is less efficient. And efficiency of the first absorber was not utilized. Right? Instead of that, transfer the major load of absorption to the first absorber. So, based on our calculation, if we operate it in a one-stream manner, and if we introduce the 5% hydrochloric acid, and if the product temperature, based on our calculation, the product temperature means concentrated hydrochloric acid solution is coming around 50 degrees centigrade. So in a one-stream operation also, it is possible to get more than 30% hydrochloric acid as a bottom product based on our calculation. But what we have suggested, you can keep the provision of recirculation. If you will not get 30% HCl, then provide the recirculation. But in any case, total flow rate of the liquid should be less than limiting value. It should not exceed that limiting value. That is 0.5 meter per second into flow area. Right? Actual flow rate of the liquid should not exceed that value. Otherwise, you will not get annular flow, and otherwise this absorber will not work efficiently. And one more problem that was faced by that industry was when they were running the plant with 100% capacity, gas was leaking through the pipe joint and flange joint of the inlet pipeline. The reason was they have not used blower. They have installed 3 large size absorber in series. But to overcome the pressure drop in an absorption system, they have not used blower. So we have suggested to use blower in between, either in between first and second scrubber or in between second and third scrubber. Not only that, all of you might be knowing that on suction side, blower is generating negative pressure. Suction side pressure of blower is about -100 to -150 mm of water column on suction side. So we have suggested to use damper valve in a suction line. In a suction line, you can provide one bypass line, they connect one extra pipeline, and to which they can attach butterfly type damper valve, and there is a negative pressure on suction side of the blower, so air will enter into the system. Air must be added in this gas mixture. When we add the air in this gas mixture, it adversely affects on the rate of absorption. It decreases the rate of absorption. But the addition of the air is essential. Otherwise, it is not possible to satisfy the norms of pollution control board. If you do not add the air, then whenever the gas that is coming out from the vent line, it is 100% pure chlorine or 100% pure HCl, while maximum permissible concentration is 30 milligram per meter cube or 25 ppm. That is only possible if we mix the air, if we dilute this gas mixture by air. So we have suggested to install the blower, not exactly in this manner. So in a suction line, where I have shown the this blower can be installed in a main line of the gas. For example, here, blower can be attached here. But on a suction side, we can attach one pipeline and here we attach damper butterfly valve. So we have given the guarantee that if we will do all this modification, then definitely this system will satisfy the norms of pollution control board. Not only that, that energy consumption will reduce from 5 lakhs rupees to 1 lakhs rupees. Similarly, I found few more mistakes. One of the mistakes that was done in a design of this pack tower type absorber, I observed that most of the fabricators of FRP pack tower, they are making this mistake. They are selecting Paul ring or modified Paul ring as a packing. But with Paul ring or modified Paul ring, they are selecting wire mesh type packing support. Wire mesh type packing support. Actually, with a Paul ring or modified Paul ring, we cannot use wire mesh type packing support. Why? Because Paul ring provides approximately 90% free area for the flow of gas. Paul ring provides 90% free area for the flow of gas. 90% free area means, suppose there is an empty tower and if the gas is introduced from the bottom, then 100% area is available for the flow of gas. Now if you put the Paul ring packing and if we introduce the liquid from the top, then after also 90% area, 90% free area, that is means 0.9 into pi by 4 di square, that is available for the flow of gas. If we select Paul ring as a packing. But with that, if we select wire mesh type packing support, then percentage free area provided by this wire mesh type packing support for the flow of gas is less than 50%. Is less than 50%. With wire mesh type packing support, certain area is occupied by the wire and through the same opening, both are flowing. Liquid is flowing and gas is also flowing. So certain area, opening area is occupied by the flow of liquid. Certain area is occupied by the packing element. Packing element is also occluded in the opening. So only remaining area is available for the flow of gas. That is less than 50%. So in a design, tower diameter is determined based on the property of Paul ring, which provides 90% free area. And with that, if we use mesh type, wire mesh type packing support, which provides less than 50% area. So in that case, in actual operation, pressure drop across the packing support is coming very high. More than, it may be more than 150 mm water column. So it can be resulted in so-called premature flooding. So because of this wrong selection of the packing support. When you operate the pack tower at design flow rate, then it may be subjected to flooding. It can be subjected to flooding because of the wrong selection of packing support. So with fall ring or modified fall ring, or even with a structured packing, we have to use either cap type or corrugated surface type packing support. Wire mesh type packing support is also called counter flow packing support, because through the opening liquid and gas are flowing in a counter current manner. Liquid and gas both are flowing through the same opening, while this cap type packing support is called separated flow area type packing support. In a cap type packing support, separate flow area is provided for the flow of gas as well as for the flow of liquid. Actually, caps are used just like bubble cap tray. Caps are used and slots are made in the cap. So ideally, gas is coming out through the slot. Total slot area is the provided for the flow of gas, while the weeping holes are provided for the flow of liquid. So separate flow area is provided for the flow of liquid and for the flow of gas. So we have to design this cap type packing support in such a way that total slot area of the caps is approximately 90% of the tower area. Similarly, we can also use this type of beam. Here also the concept is same. This liquid is falling down through the horizontal plane, weeping holes, and slots are made for the flow of gas. Next slide. Corrugated surface type packing support. So here slots are made for the flow of gas in a corrugation, and weeping holes is provided in a horizontal plane for the flow of liquid. So this is also one more common mistake that I observed that is done by fabricators. And majority of the consultant for the design of pack tower type absorber, they are using ChemCAD software. But I found that design of the given by ChemCAD software is wrong. ChemCAD software is not calculating the correct value of actual amount of solvent. Actual amount of solvent calculated by ChemCAD software is wrong. One major point that is not considered in calculation, that is heat of solution. Just now I told you that absorption of HCl in water is highly exothermic. So when we design the pack tower type of absorber for the absorption of HCl in water, the important point in design is we can allow the recirculation of the solvent, but per pass rise in temperature of the liquid solvent, per pass rise in temperature of the liquid solvent should be less than 10 degrees centigrade. But for a highly exothermic absorption, actual solvent rate required, for example, for absorption of HCl in water, actual solvent rate required is nearly 45 times higher than the minimum amount of solvent. 45 times higher. While this software is calculating 10 times higher. That is wrong. So if you will follow the software, then it will not give the desired performance. So here I stop. This is can be FRP or FRP is the better. Otherwise, it can be polypropylene also. But strength of FRP is higher. તો ડિઝાઇન પરફેક્ટલી કરેલી હોય અને ઓપરેટ પણ આપણે પરફેક્ટલી કરતા હોઈએ તો પોલ્યુશન ડેફિનેટલી 0% રહી જશે. 2 વર્ષ પહેલા જ મેં થાઇનાઇલ ક્લોરાઇડ માટે સિમિલર એબ્સોર્પ્શન સિસ્ટમ મેં ડિઝાઇન કરેલી. એમણે મને ફીડબેક આપ્યો કે અત્યાર સુધી મેં 15 પ્લાન્ટમાં મેં કામ કર્યું છે થાઇનાઇલ ક્લોરાઇડના પ્લાન્ટમાં. હંમેશા થાઇનાઇલ ક્લોરાઇડના પ્લાન્ટમાં અમે એબ્સોર્પ્શન સિસ્ટમથી દૂર જ ભાગીએ, કારણ કે કેટલો બધો ગેસ લીક થતો હોય. એમાં SO2, HCl અને ક્લોરિન. કારણ કે તમારી ડિઝાઇન એટલી પરફેક્ટ છે કે અમે ચા નાસ્તો કરવા માટે એબ્સોર્પ્શન સિસ્ટમ જોડે જ બેસીએ. બિલકુલ જરા પણ લીકેજ નથી. એટલે આપણે અનનેસેસરીલી બધું સેવિંગ કરીએ, જ્યાં કુલર પ્રોવાઈડ ના કર્યું. હવે એની સામે કોઈ આર્ગ્યુમેન્ટ એ કરે છે કે કુલર પ્રોવાઈડ કરીએ કે ના કરીએ, અમારે તો જે આપવાના છે આપવાના જ છે. હું કહું છું કે તમે બધું ભૂલી જાઓ, તમારી હેલ્થનો વિચાર કરો, બીજું બધું ભૂલી જાઓ. કારણ કે આ ક્લોરિન ઇઝ હેવીયર ધેન એર. જે બધો ક્લોરિન બહાર જાય છે ત્યાં પ્લાન્ટમાં જ સેટલ થાય છે. ઝીરો થઈ જાય છે ને. અને ફોરેન કન્ટ્રીઝમાં બધાને અનુભવ છે, જેણે ફોરેન કન્ટ્રીઝમાં પ્લાન્ટ વિઝિટ કરી હશે એ બધાને એક્સપિરિયન્સ થયો હશે કે અહીંયા તો પોલ્યુશન જેવું લાગતું જ નથી. એવું કેવું એમણે કે એવું જાદુ નથી, અને આ ટેકનોલોજી અવેલેબલ જ છે, પણ આપણે એમાં સેવિંગ કરીએ છીએ કે
after the batch completion and the process over, any second scrubber will get to
સેકન્ડ સ્ક્રબરમાં તો
last night the batch process completed. Highly acidic.
હા
Yeah. That was suffered from the last 15 days before. And you have to aware. આ વસ્તુઓ આપણને પ્રેક્ટિકલ નોલેજ
એમને એટલે તમે શું પ્રોબ્લેમ શું થયો એમ કોને કોને મેં શું કહ્યું કે અમાર એ લોકો જે કરતા હતા એ પ્રમાણે 20%
પ્રોસેસ પતી ગયા પછી બેચ કમ્પ્લીશન પતી ગયા પછી if they are writing in the report સ્ક્રબર ની pH value less than 2 છે તો એ તો રહેવાનું છે ને,
એ તો રહેશે જ.
તો એ વસ્તુ આ તકલીફ પડી જશે. એ પ્રેક્ટિકલ અને
એમને એટલા માટે આપણે એમને પ્રેક્ટિકલ નહીં, એના માટે હાઇડ્રોક્લોરિક એસિડ માટે આપણે પોલીપ્રોપેલિન પંપ યુઝ કરવો પડે. બધા જ જેમ તે મેં કહ્યું કે કુલર પણ ગ્રેફાઇટમાંથી બનાવવું પડશે. એટલે કોરોઝનનો પ્રોબ્લેમ નહીં થાય તો પછી કોરોઝનનો કોઈ તો બીજો કયો પ્રોબ્લેમ તમારે ફેસ કરવાનો થાય છે કોરોઝન સિવાય? હા હું સમજી ગયો, પણ તમારે કયો પ્રોબ્લેમ ફેસ કરવાનો થાય છે એમ? તો એસિડિક જ થાય ને. આપણે 5% હાઇડ્રોક્લોરિક એસિડ બનાવી કે 20% બનાવીએ એ તો એસિડિક જ થવાનું. પીએચ કોણ સપોર્ટ કરે? નહીં એટલે આમાં જેમ કે 5% બનાવ્યું તમારે, એને તમારે સ્ટોરેજ ટેન્કમાં ટ્રાન્સફર કરવાનું છે. અને સેમ તમારે હા લાસ્ટ ક્રમાંક ન્યુટ્રલ જ છે. હમ. જે રીતે આમાં એનએચ સ્ક્રબર જે છે એમાં ન્યુટ્રલ જ બહાર આવવું જોઈએ. એટલે ઘણા આમાં આ કેસમાં એવી આર્ગ્યુમેન્ટ કરે છે કે તમે તો ડિઝાઇન પરફેક્ટ કરો છો તો પછી આ ત્રીજા સ્ક્રબરની જરૂરત ક્યાં છે. એટલે આ કેસમાં નહીં, આમાં તો ક્લોરીન છે એટલે જરૂર છે જ. પણ જેમ કે પોલીવિનાઇલ ક્લોરાઇડ પ્લાન્ટ છે તેમાં ખાલી HCl જ જનરેટ થાય છે. એટલે એની પીએચ તો 2 થી ઓછી જ રહેવાની, બરાબર છે. એટલે તમારે પોલ્યુશન કંટ્રોલ બોર્ડને ક્યાં તો એનો એટલે આલ્કલી સ્ક્રબર તો લગાવવું જ પડે. મેં કહ્યું ને પોલીવિનાઇલ ક્લોરાઇડમાં તો ખાલી હાઇડ્રોજન ક્લોરાઇડ ગેસ જ જનરેટ થાય છે. પોલીવિનાઇલ ક્લોરાઇડમાં ખાલી હાઇડ્રોજન ક્લોરાઇડ ગેસ જ જનરેટ થાય. ક્લોરીન 100% પ્યોર હાઇડ્રોજન ક્લોરાઇડ. એમાં એ જ આર્ગ્યુમેન્ટ થઈ કે એમાં તો કોસ્ટિક સ્ક્રબરની જરૂર કે તમે જો પરફેક્ટ ડિઝાઇન કરેલું હોય વોટર સ્ક્રબર તો પણ જરૂર છે જ. આ બધા ઇક્વિલિબ્રિયમ લિમિટેશનને લીધે HCl તો આગળ જશે જ, એસ્કેપ થશે જ. એટલે એના માટે બીજું સ્ક્રબર જોઈશે જ, કોસ્ટિક સ્ક્રબર. એટલે એમાં ના, એટલે સિલેક્શન કે શું છે કે ફોર એબ્સોર્પ્શન ઓફ HCl in water, PEG towers are also used and graphite block type falling pin absorber is used. But selection criteria is if the feed gas contains more than 40% HCl, feed gas mixture contains more than 40% HCl, then graphite block type is better than PEG tower. But if the feed gas mixture contains less than 40% HCl, then PEG tower is better than graphite block. આમાં તો 90% HCl છે એટલે પહેલું એબ્સોર્બર ફોલિંગ ફિલ્મ એબ્સોર્બર જ હોવું જોઈએ.